Imagine being able to sort of peer inside yourself, seeing the electrical signals, zapping around in your brain.
Or the power in your muscles.
Exactly, surging through your muscles.
Yeah,
And
right.
visualized like in real time on dynamic charts. It sounds incredibly complex, right?
It really does.
I mean, how do you even start to take that raw biological data? It's so intricate, whether it's brain,
Mm.
heart, muscles,
Hmm.
and turn it into something you can actually see, something you can understand, interact with, without needing like 5 different PhDs.
Yeah, that's really the core challenge, isn't it? Working with biomedical data is incredibly rich stuff.
But maybe overwhelming.
Oh, definitely overwhelming sometimes. Often it's kind of locked away in complex formats or you need these specialized tools.
Right, which are probably
Often
expensive.
very
Yeah.
expensive, yeah. And just not accessible to everyone who might be interested.
Okay, and that really gets to the heart of this deep dive.
Mm.
We've been looking into source material about this platform. It's called BioniChaos.
Hmm.
And it seems like it's specifically built to, well, tackle that exact accessibility problem head on.
Yeah, the sources definitely frame it that way. Like, BioniChaos is this hub really aiming to pull back the curtain on biomedical data processing.
Slide the curtain. I like that.
And their stated mission, it's quite clear in the material, is basically to democratize access to these kinds of tools and resources
Right. Okay. So making them available not just for the high-level researchers, but
for a much wider audience.
yeah.
Exactly. Researchers, sure, but also educators, students.
Students too.
Yeah, particularly the sources mentioned in fields like, say, biomedical engineering or neuroscience.
Makes sense. So it's about opening up data that was maybe pretty closed off before.
Precisely. Making it less about, who has the fanciest software or the cutting edge lab, and more about enabling anyone who's interested to actually explore this stuff, to learn, to work with this really fascinating data.
Okay, so let's dive into how they actually tackle this data challenge.
Yeah.
Our sources, they highlight a pretty wide range of tools that BioniChaos offers.
Yeah, it's quite broad.
Seems like everything from like core data analysis stuff to these platforms that are described as highly interactive, advanced software solutions even.
Mm-hmm. And what's really interesting is just the breadth of biological signals they cover.
Okay.
The sources point to tools for visualizing, analyzing, well, everything from brain signals,
Like EEG?
EEG, yeah, and also IEEG, and then looking at muscle activity, so EMG specifically,
EMG, okay.
and even exploring heart rhythms with tools for ECG and PPG data.
Okay, let's maybe pause there for a sec because those acronyms, they can sound a bit daunting.
Sure.
So EEG and IEA, that's electrical activity in the brain, yeah.
Mhm.
EEG is outside the skull, electrodes on the scalp.
That's right, standard clinical EEG.
And IEG is inside the skull, like
Oh,
more invasive.
exactly. Intracranial EEG. Often used in specific medical cases like epilepsy surgery planning. Think of it as different ways to listen to the brain's electrical symphony.
One from afar, one up close.
Yeah.
Got it.
And EMG is similar but for muscles, recording the electrical signals when muscle fibers contract.
Right. And ECD is the heart's rhythm, the EKG we know from the doctor's office.
Yep. And PPG, that's related to blood volume changes, often measured with light, like on your smartwatch tracking your pulse.
Ah, okay. So BioniChaos provides ways to look at all these fundamental internal signals.
Mm-hmm.
And the sources mentioned specific tools for this, right? Like for muscle data.
Myoscope.
Yes, Myoscope for analyzing EMG. And they even mentioned Myomock.
Myomock, a simulator.
Yeah, simulator,
Right.
which is interesting because it lets you actually create synthetic EMG data.
Oh, neat. So you could test things out.
Exactly. Test analysis techniques or just play around, see how changing parameters affects the signal without needing, a real person hooked up.
That makes a lot of sense for learning. Totally. And for heart data, there's PulseViz, another tool, this one for visualizing synthetic heart rate data.
Synthetic again.
Yeah, so you can tweak factors like oxygen saturation or maybe introduce noise and see how that messes with the signal visually.
That simulation aspect seems really key for learning, for experimenting safely.
I think so.
Okay, what about the brain data tools? Beyond just looking at the raw, squiggly lines, what else can you do? What analysis do they make accessible?
Well, the sources detail tools like EGView, that's for general EEG visualization, but they go deeper too. There's a spectrogram tool, for instance.
A spectrogram. Sounds complex. What does that actually show you?
Okay, think of it like a musical score, but for your brain activity. So
Yeah.
instead of just seeing the signal wiggle up and down over time, a spectrogram shows you the frequencies within that signal, how the different frequency bands change over time.
Ah, so like, are the low frequencies dominant now or the high frequencies?
Exactly. Lower frequencies might be linked to sleep or relaxation, higher frequencies to active thinking or concentration. Seeing this visually is, well, it's crucial for understanding different brain states or how the brain responds to something.
Right, so you're seeing patterns you totally miss just looking at the raw data trace.
Precisely.
And they have versions of this for both the surface EEG and that intracranial IEG.
Yep. The sources mention IEG spectrums specifically for analyzing frequency content in that internal brain data. They even have a denoising version.
The noising, getting rid of the noise.
Yeah, using techniques like wavelets.
Wavelets.
Yeah.
Okay, another technical term drop.
hmm
Briefly, what do wavelets do here? How do they help?
Okay, so wavelets are these really powerful mathematical tools. They help us break down complex signals like EEG into simpler components, but across different scales or resolutions.
Mm, okay, like zooming in.
Sort of. Imagine trying to separate out all the instruments in an orchestra playing at once, the low rumble of the bass, the sharp hit of a drum, the long notes of violins. Wavelets help kind of isolate those different types of signal components, which is incredibly useful for filtering out unwanted noise, like muscle artifacts in EEG, or for spotting specific, maybe subtle patterns buried in the data.
That sounds super useful, especially, yeah, with biological signals, which can be notoriously noisy.
Definitely.
And speaking of specific patterns, the sources highlighted tools focusing on some pretty specific clinical applications, like using something called joint time frequency scattering for seizure detection in EEG. That sounds advanced.
It is pretty advanced stuff. Joint time frequency scattering, it's a relatively cutting-edge technique in signal processing.
So having that in a platform like this.
That's a great example of that democratization mission we talked about, right? It's not just providing like the basic tools, it's making some serious analytical power accessible.
And applying it to seizure detection.
Yeah, it means researchers, maybe clinicians, could potentially develop or test methods to spot those critical patterns in brain activity faster, maybe more accurately.
Wow, okay. That potential to improve diagnosis or treatment down the line, that's really powerful. And the sources mentioned Seizure Zone too, a 3D brain mapping tool.
Yes, seizure zone. It lets you visualize which areas of the brain might be involved during seizure activity, often using data you get from techniques like the ones we've just discussed.
So you can actually see where in the brain things are happening.
Kind of, yeah. See the geography of the activity.
Okay, this brings up a really important point. How do you make these abstract concepts, this complex data, visual and understandable? Not just for the experts, but for students, for newcomers.
Yeah, that's crucial.
The sources mention tools that seem designed exactly for that, like BioVen.
BioVen is a great example for that. It visualizes how different biomedical fields intersect using a Venn diagram.
Oh, okay. Simple concept.
Super simple, intuitive concept, right? Overlapping circles showing common ground, but applied here to show how different areas of biomedicine, ones that might seem totally separate, actually connect and overlap.
So it helps you grasp those interdisciplinary links visually.
Exactly. Much better than just reading a list of fields.
And my personal favorite example, from the sources anyway, illustrating this power of visualization, is the data source doesn't. You have to explain what that shows us.
Oh, the data source doesn't. It's fantastic, isn't it?
It's brilliant.
So it takes 12 different data sets,
Okay.
12 sets of points, and for all 12, the basic summary statistics are exactly the same.
Like the average, the standard deviation.
The mean, median, standard deviation,
Okay.
even the correlation coefficient, identical across all 12 data sets.
Okay, so on paper, they look the same if you just run the numbers.
Exactly. But
Yeah.
then you plot them, you actually visualize the data points,
Yeah.
and they look dramatically, wildly different.
Yeah.
One might be a nice straight line, another just a blob of scattered dots, another one looks like
A dinosaur.
a dinosaur.
Yeah.
Literally, the points form the outline of a dinosaur.
It's amazing.
It is, and it's such a powerful, memorable way to show that you absolutely cannot rely on summary statistics alone.
You just can't.
You have to visualize your data. You have to look at it to find the hidden patterns, to understand its real shape, its distribution.
And avoid being totally misled by numbers that look identical.
Precisely.
It really hammers home how vital visualization is.
Mm.
For getting those aha moments about data you'd otherwise completely miss. It really connects back to your goal as a listener of wanting to gain knowledge quickly, but also thoroughly.
Absolutely. Seeing these principles visualized is just so much more impactful than reading about statistical pitfalls in a textbook.
For sure. And the platform includes other tools too, right? Things
Yeah.
that might seem a bit different, but maybe rely on similar underlying ideas.
Yeah, they mention a hearing test tool, for example,
Yeah.
with real-time visualization, and you can download an audiogram.
Okay.
And also an image compression tool that uses wavelet transforms.
Ah, wavelets again.
Yeah, the same technique we talked about for denoising brain signals.
So that shows the versatility, right? Applying these signal processing techniques like wavelets, not just to brain waves or muscle signals.
But across different types of data, audio in the hearing test, images in the compression tool, and that complex brain activity we discussed.
Interesting.
And they even touch on mental health. There's something called mental ang mentioned.
Mental ang.
Yeah, framing mental health or aspects of it in an engineering context like a dynamic system.
Framing mental health as a dynamic system.
Mm.
What does that actually imply? What does that mean?
Well, it suggests you could potentially model aspects of mental states or processes using concepts that are familiar in engineering. Things like signal processing, system dynamics. It offers a different kind of lens, potentially allowing you to identify dynamic shifts or patterns using more objective measures, maybe complementing the traditional subjective assessments. It's definitely an intriguing way to approach a really complex area.
It really is. And looking ahead, they mention NeuroGPT, suggesting integrating advanced AI like GPT models with EEG data analysis.
Yeah, that points towards exploring some really cutting-edge applications in the future.
So they're not just sticking with current tech.
Seems not. It indicates they're looking at how the latest AI advancements might be applied to help decipher complex neural data, really pushing the boundaries.
Okay, so let's try and recap a bit. We've seen how BioniChaos, based on these sources, offers this really remarkably diverse set of tools,
It's quite a range.
covering everything from those fundamental biological signals, brain activity with EEG and IEG, muscle signals via myoscope, and that MyoMox simulator.
Heart rhythms with ECG and Pulsiviz.
Right. Even explorations into mental health modeling with Mentalizan. And those crucial general data concepts like the data source doesn't, showing why you need to visualize.
Or BioVin showing how different fields connect.
Yeah. And what seems really powerful here, connecting it back, is how these interactive tools and visualizations directly tackle that challenge of understanding complex stuff.
Things like the Datasaurus or BioVen, they aren't just, showing data points. They're illustrating principles. Principles about data analysis, about how fields relate in a visual way that's just much easier to grasp than reading paragraphs in a book.
Absolutely. And the sources were clear. This isn't just for the pros, right? They specifically mention resources, project proposals aimed at students.
Yeah, underscoring that educational aspect. Making these complex tools genuinely accessible for learning, for hands-on exploration.
Which makes learning and research too, I guess, way more engaging.
Definitely. I mean, instead of just reading definitions of, say, EEG frequency bands or how wavelet denoising is supposed to work,
Right.
you could potentially use their tools like the EEG band power visualization or the IEG spectrum denoise to actually explore those concepts directly, hands-on.
And things like the hearing test or the image compression tool.
They provide really tangible applications you can interact with. It brings the theory to life, makes it much less abstract.
Okay, this opens up some really fascinating possibilities, doesn't it? So here's a final thought, maybe something for you, the listener, to mull over building on all this. Given this increasing power we have to visualize and analyze these really fundamental biological signals, brain activity, muscle signals, heart rhythms, even models of mental states, how might understanding these internal signals through accessible tools like the ones BioniChaos is aiming for, how might that fundamentally change our approach? Our approach to health monitoring, maybe personalized learning, or even just our own personal well-being in the future?
Okay, settle in, everyone. We're about to dig into some really interesting source material you've shared with us. Today, we're unpacking an advanced EMG signal simulator.
Right, EMG. And just quickly, that's electromyography. It's basically, a technique for measuring the electrical buzz muscles give off when they work.
Listening to muscles talk, essentially.
Pretty much, yeah. And this source describes a web app, a simulator, built to let you record and visualize that EMG data. Looks like they really aimed for a user-friendly interface.
Yeah, making complex stuff approachable. So our mission, let's say, for this deep dive, figure out the core features, and maybe more importantly, what this simulator actually helps us explore about these muscle signals. Like, what do you learn by playing with it?
Good question. So the source lays out the basics first. Generating a signal, you've got standard controls, start recording, stop recording, simple enough,
Makes sense. Start, stop.
and a clear data button too, to wipe the slate clean.
Okay. But the interactive part seems to be this flex button.
Exactly. That's kind of the core simulation element. You click it, you hold it down, and that simulates a muscle flexing. The source even mentions it turns yellow, so you get that visual feedback.
Ah, okay. And when you let go.
Simulation stops. The muscle relaxes, electrically speaking.
Right. And that action, that clicking and holding, it translates into this electrical signal you see on the screen.
Precisely. And here's where it gets interesting. You can control the character of that signal. There are sliders for that. First one is the noise level slider.
Noise. Why simulate noise?
Well, real biological signals are never perfectly clean, right? There's always background electrical activity, maybe some interference. This slider lets you add that in. You can see what a slightly messy or a very messy signal looks like, which is, realistic.
Okay, so it adds realism. Makes sense. What's the other slider?
The flex level slider. This one controls the simulated intensity of the muscle contraction.
Ah, so like flexing harder versus just a little twitch?
Exactly that. Crank up the flex level, you simulate a stronger effort. And you see that reflected in the signal, usually a higher amplitude, taller peaks.
So you can directly see how effort impacts the electrical output. That's cool.
It's fundamental for understanding EMG, yeah. How signal size relates to, well, force or effort.
All right, so we're generating signals, we're tweaking their intensity and noise. How do we actually view this data effectively? The display options.
Yep. There's a time window slider. This adjusts how much time or how many data points you see on the graph at once.
Like zooming in on a short burst or zooming out to see a longer period?
Exactly. Lets you focus on details or see the bigger picture.
Useful. And a grid. I see a show grid checkbox mentioned.
Yeah. Just adds horizontal and vertical lines to the graph. Makes it easier to, estimate the actual voltage values by eye. Standard graph feature, but helpful.
And auto scale. What's that do?
If you check that box, the graph automatically adjusts its vertical scale, the y-axis, to fit whatever signal is currently displayed. So if you have a really small signal, it zooms in. If you suddenly have a huge spike from a strong flex, it zooms out so you can still see the peak. Keeps everything visible.
Okay, keeps things tidy. Now, it's not just about the visual line, is it? The source says it provides real-time metrics, numbers.
Correct. 3 key ones are highlighted. First is peak amplitude.
Which is just the highest point the signal reaches.
Yep. The maximum value recorded in that little window of time gives you an idea of the sort of maximum instantaneous electrical activity.
Okay. Then there's RMS value, root mean square. That sounds a bit technical.
It does, but it's super important in EMG. Think of it not as the peak, but as the overall effective level or power of the signal over time. Like the average signal strength, but calculated in a way that properly accounts for the ups and downs. It gives a much better sense of the sustained activity level than just a simple average.
So peak is the absolute top spike. RMS is more like the general energy level.
That's a good way to put it, yeah. RMS is very commonly used to quantify muscle activation.
Gotcha. And the last one mentioned is mean value,
which is just the simple mathematical average of all the data points in the window. For typical EMG signals that fluctuate around 0, the mean might not be as informative as RMS, but it's still a basic statistical measure the simulator provides.
Right. And the source ties these metrics back to real-world uses.
It does. It mentions things like muscle activity analysis, maybe tracking fatigue, or even uses in rehabilitation monitoring how muscle activation changes over time as someone recovers. Understanding peak RMS mean is key there.
And it really pushes you to experiment, doesn't it? Change the noise, change the flex level, see what happens.
Absolutely. That seems to be the core idea. Learn by doing. See how cranking up the noise might make it harder to get a stable RMS reading, or how the peak amplitude jumps way up with the flex level.
Okay, so let's wrap this deep dive. We've seen this EMG simulator provides this really hands-on way to explore muscle electricity. You can generate signals simulating flexing, tweak them with noise and intensity, view them clearly with display tools, and get key numbers like peak amplitude, RMS, and mean value in real time.
And the big takeaway from the source seems to be
Yeah,
play with it, experiment. That's how you connect the controls to the output.
right. Which leads us to a final thought for you, the listener. The source material really encourages you to experiment, change the noise, change the flex intensity, and watch how those metrics like peak amplitude, RMS, and mean value react. So think about this. What does observing those specific relationships in the simulator, how noise affects RMS, how flex level affects peak pick? What does that teach you about the real world challenges and, let's say, the nuances you face when trying to interpret those same metrics from messy, complex EMG signals coming from actual human muscles? Something to ponder.
Okay, so think about trying to understand signals from your own body. Like those squiggly lines on an ECG or the really complex rhythms from brain waves from an EEG.
Uh-huh.
It's data that's just packed with potential insights,
Yeah,
right?
absolutely. Huge potential.
But actually working with it often feels like, well, hacking through a jungle. It's dense, it can seem chaotic, and usually you need pretty complex, often expensive tools or just really deep technical know-how.
Right. There's this incredible treasure trove of information just sitting there, but getting at it and figuring out what it actually means, that's been a huge barrier for a lot of people, outside of specialized labs.
Yeah.
It's a field that's just begging for exploration, but the tools haven't always been, well, easy to get your hands on.
Exactly. And that challenge, that barrier, that's precisely what we're diving into today. We're looking at a project called BioniChaos.
BioniChaos. Yeah, it's a name that kind of neatly sums up the complexity it's trying to tackle, doesn't it? That mix of biology and electronics, the biosignals, which honestly can seem pretty chaotic at first glance.
For sure. So our mission in this deep dive is to pull directly from the project's own material. We want to understand what bionic chaos actually is, what it offers you, the listener, and why it's a really interesting development if you've got any curiosity at all about biomedical data. Whether you're, say, a student, a tech enthusiast, maybe a researcher, or even a healthcare professional.
Right. The goal really is to help you navigate this specific kind of chaos, see the potential the project might unlock, and show you how you could maybe start engaging with this fascinating data yourself, without needing to build your own lab from scratch.
Okay, so let's kick things off. What exactly is bionic chaos at its core?
Well, at its heart, BioniChaos is an open source initiative. Its main mission, and they state this pretty clearly in their material, is to democratize biomedical data processing.
Democratize.
Yeah, think of it like trying to lower that barrier to entry we were just talking about, making powerful analytical tools and resources accessible to a much, much wider audience.
That's a strong word, democratize, especially here. It really suggests breaking down those walls. And this isn't some huge institutional thing, is it?
No, not at all. And that's what's kind of fascinating. It actually started out as a personal project.
Really?
Yeah, born from the passion and, the experience of a biomedical engineer and data scientist who just saw this need, this gap for more accessible signal processing tools. It really grew out of their own work and expertise, especially, it seems, with data like EEGs, brain activity, and also ECGs for heart signals.
So it's someone who genuinely gets the pain points of working with this stuff, who built a solution. That background with EEG and cochlear implants, that must be incredibly useful for developing these kinds of tools.
Oh, definitely. It gives a really solid foundation, understanding the nuances, the complexities of neural signals, physiological signals. And the project material suggests they're keen to explore and add more types of biomedical data over time, too. So it's not static. It's a living, evolving platform.
Okay, so it's open, it started personal, it's aiming to democratize access.
Right.
What's the specific problem it's trying to solve, like on a practical level?
The main thing is bridging that gap. Biomedical data, it's complex, right? It's noisy, it changes constantly, and pulling out meaningful patterns, well, that takes sophisticated analysis.
Right.
BioniChaos aims to simplify that processing, make it easier to understand. The vision isn't just handing over tools, it's about creating an open, user-friendly platform that actually empowers people to explore and analyze, and they back that up with educational resources, too.
It sounds like they're saying, look, here are the keys to the data kingdom, and here's a map to get you started.
That's a pretty good way to put it, yeah. And a really key part of that empowerment is how you actually interact with it. The project offers things like dashboards, web applications, APIs,
Right.
and crucially, you don't necessarily need to download or install anything to get started with the examples.
Wait, really? So I don't need special software installed on my machine?
That's a major point about accessibility. For the example applications they provide, you can often use them right in your web browser. On your laptop, even potentially your smartphone, although they do note the site works best on a desktop for the analysis tools. You basically just select an application on their site, and you can start exploring the sample data right away.
Wow, that is incredibly user-friendly. Just click and start tinkering. And what kind of data can you, play around with using these tools?
The materials specifically mention support for EEG and ECG data. That makes sense given the developer's background.
Right, brain and heart.
Exactly. They also mention potential for other signals like PPG photoplethysmography that's often used in wearable sensors for heart rate or oxygen saturation. So it covers brain activity, heart function, and maybe even data from devices you might wear every day.
Got it. So, okay, if someone wants to dig a bit deeper, maybe build on what's there. What's going on under the hood? What are the technical capabilities we're talking about?
Well, the platform gives you the code you need, mainly in JavaScript for the web stuff, but they also provide Python snippets where that makes sense. It's designed to be pretty self-contained. The real power, though, comes from the range of signal processing techniques that the tools demonstrate.
Okay, and that's where things can get technical fast. What kind of analysis techniques are we talking about?
Yeah, this is where you see it goes beyond just showing you the squiggly lines.
Yeah.
The tools offer practical examples covering things like statistical analysis, fuzzy logic, neural networks, spectrogram analysis, even some image processing and classification techniques, but applied to representations of the signals.
Okay, let's pause there for a sec. For someone maybe not deep in signal processing, what does using, say, spectrogram analysis or a neural net on EEG data actually help you figure out?
Right, good question. Think of it like this. A spectrogram helps you see how the frequencies inside a signal, like different brainwave rhythms, alpha, beta, whatever, change over time.
Ah,
That's really crucial for spotting patterns, like maybe different sleep stages or potentially signs of seizure activity. And using tools like neural networks, which are a type of AI, lets you train models to find really subtle patterns or predict events within that data, stuff that a human eye might just completely miss.
I see.
So the purpose of these examples is really to help you figure out specific characteristics of the signals, maybe predict events or spot irregularities, essentially to get a deeper understanding from what might just look like noise at first.
So turning that raw, messy data into actual insights or predictions.
Hmm.
And you mentioned AI frameworks, like TensorFlow and PyTorch were in the material.
Yes, exactly. That's where the AI analysis part comes in. Some of the tools within BioniChaos actually use these standard AI frameworks to do the heavy lifting on complex data analysis. It's also interesting they mentioned that AI tools like ChatGPT and GitHub Copilot were used in the development process itself, like helping write code or even some of the explanations on the site.
Huh, so AI helps build the tools, and AI is in the tools doing analysis. That's kind of a neat loop.
It is, and there seems to be a bit of a philosophy there too about how users interact.
Oh.
Yeah, there's this idea mentioned that sometimes well-crafted prompts or guided interfaces can replace the need for users to write tons of code themselves, especially for common analysis tasks.
Right, which ties back into that democratization goal, making complex stuff accessible even if you're not a hardcore coder.
Exactly.
Okay, so you've got these powerful tools and techniques ready to go. Where's the data coming from that you're analyzing in these examples?
Yeah, the material is very clear about this. Any raw data used directly in the BioniChaos website's example tools is de-identified. It's all sourced from the public domain.
Okay.
And they make a point of trying to mention the exact source for each example data set they use.
Right, using public data is great for learning and experimenting, but what if you have your own data, maybe from a personal project or research? Can you upload that?
Ah, good question. Currently, direct upload of your own, possibly confidential data to the main BioniChaos site isn't a feature.
Okay.
The recommendation they give in the source material is to use other publicly available data sets if you want to practice. Places like PhysioNet or GitHub have loads of this stuff.
Gotcha.
They do mention a related project, bionicloud.com, as maybe a future option for handling confidential data, but they're clear that it's still under development, so not quite ready yet.
Good to know the options there. And since it's open source,
Mhm.
what does that mean for how people can actually use the tools, the resources, everything BioniChaos provides?
Right, the license. Everything on BioniChaos is under a Creative Commons Attribution License, CC BY,
Which means?
which is incredibly permissive, actually. It means you can use the content, the tools, the code snippets, pretty much anything on the site for almost any purpose you want. That includes commercial applications.
Wow, okay.
The only catch, the only requirement is attribution. You just need to mention BioniChaos as the source. Give credit where it's due.
That really open license definitely underlines that democratization mission we talked about.
Yeah.
So who are they really aiming this project at? Who's the intended audience?
Well, the target audience seems pretty broad, which again fits the mission. They explicitly list researchers, students, tech enthusiasts, and healthcare professionals.
So quite a mix.
Yeah, basically anyone who's interested in biomedical data science or maybe brain-computer interfaces, BCIs, or artificial intelligence, AI, or just curious about that whole intersection of biology and tech. If that sounds like you, this project is probably aimed your way.
And is the developer just working away in isolation? Or is there room for the community to get involved? But open source often implies collaboration.
Oh, absolutely. Collaboration is definitely encouraged. It's vital for projects like this. The developer makes it clear they welcome suggestions, big reports, contributions.
Contributions like code or...
Could be code, could be helping analyze data, maybe developing new tool ideas, or even just providing feedback on usability, like how easy or hard is it to actually use this stuff. They seem very open to input.
That's great.
And there's even a specific page on the site they mentioned for potential student projects, which seems like a fantastic way for students to get involved, contribute something real, and get experience.
Yeah, that sounds brilliant for fostering learning and development.
Yeah.
And what if someone's looking for just more general resources beyond the BioniChaos tools themselves?
They've got that covered too. The site has a resources page, and this page lists various other open access biomedical data sources, other relevant tools maybe, data sets, basically pointers to help people explore further on their own.
Okay, great. Now, before we wrap up, there are some really important practical and ethical points mentioned in the source material. We absolutely need to make sure those are clear. Let's start with the basics: security and privacy.
Right. Security is stated as a priority. They say the site is built to be secure. And on privacy, the project really emphasizes wanting a lightweight and private user experience. They explicitly state they don't use third-party analytics or tracking tools.
So my activity on the site isn't being tracked by like Google Analytics or similar companies?
Correct. That's what the material says. The only third-party thing they mention is Google AdSense, which they use just to show some ads to help cover server costs.
Okay.
And crucially, they state that no personal information is collected from users. You don't have to sign up, give your name, your email, nothing like that to use the site and its examples.
That focus on privacy, especially when you're dealing with potentially health-related data, that feels really significant.
It does.
Now, there's a disclaimer. A disclaimer associated with the project that is, well, it's quite striking.
It is indeed, and it's absolutely critical that anyone looking at BioniChaos understands this part.
Yeah.
The disclaimer is very explicit. The site and its tools are not certified for clinical or commercial use, period.
Not for doctors' offices or anything like that.
Definitely not. It's presented as an experimental site, provided as is, which is standard legal speak, meaning, there could be bugs, errors, inaccuracies.
Yeah.
Use at your own risk.
And the material really hammers this point home, right? Connecting it back to the experimental nature.
Precisely. It absolutely must not be used for making clinical diagnoses or any kind of medical decisions. And the developer goes on to state with considerable emphasis that they are not liable for a whole range of potential bad outcomes if you misuse it.
And this is where the language gets memorable. What's on that list of things they're not liable for?
Right. Well, slight pause. It includes the expected things like financial loss, misdiagnosis, loss of data. But then it also lists nuclear holocaust and zombie apocalypse.
A beat? Okay.
Yeah.
Right. Nuclear holocaust and zombie apocalypse. That certainly gets your attention. It definitely highlights the extreme, maybe hyperbolic end of potential negative outcomes.
It really does. And obviously those specific items are using hyperbole to make a very strong point. But the core message underneath that is dead serious. The creator takes no responsibility if you misinterpret data leading to misdiagnosis, or if you lose money or lose data using these tools.
Yeah.
It's a crystal clear signal. This platform is for learning, for exploring, for developing ideas. It's a tool for curiosity. It is not a certified medical device. It's not a tool for making critical decisions about health or finances.
That distinction is absolutely paramount for anyone thinking of using these tools. And there was one other very specific prohibition mentioned too, wasn't there? Something about its use.
Yes, that's right. Military use is explicitly prohibited. The material, the tools, the resources, none of it is supposed to be used for any military purposes or military research or development. They state the mission is peaceful and educational.
A very clear ethical stance there. Okay. Finally, if this project, its mission, resonates with someone listening and they want to maybe help ensure it continues, that it grows, how can they support it?
The material mentions a couple of ways. You can support the project through Patreon or by becoming a YouTube member on their channel.
Okay.
And they actually give a shout out thanking their current supporters by name: Johan Matthias, Mashnun Tisam, Salim Huda, Andrew Stevens, and Cody Aston. Which is nice. It highlights that community aspect again.
Definitely. So let's bring this all back to you, the listener. Why does a project like BioniChaos actually matter in the bigger picture?
Well, it matters because it's actively trying to solve that first problem we talked about, the complexity, the inaccessibility of so much biomedical data. It's really lowering the bar for entry into these incredibly exciting fields that touch on health, neuroscience, technology, AI.
Yeah, it takes what seems like really intimidating data,
Right.
whether it's EEG, ECG, maybe other stuff, and puts practical tools and learning resources right into your hands.
Yeah.
It empowers you to go from just being curious about this stuff to actually engaging with the data yourself,
Mm-hmm.
experimenting, maybe even contributing back to this open ecosystem,
Mm-hmm.
and crucially, without needing to invest in, specialized, expensive gear right from the start.
Exactly. It's really a pathway for fostering curiosity, for learning, and hopefully for sparking some innovation in a field that's just becoming more and more relevant to all our lives.
And if you want to see some of these tools in action, maybe get a more visual feel for what BioniChaos offers, the material points to their YouTube channel is a great place to start. You can find that at youtube.com/@BioniChaos.
Yeah, definitely check that out. And as you think about what BioniChaos is doing, maybe consider that tension we discussed. It was really highlighted by that very memorable disclaimer, wasn't it?
Yeah, it definitely was.
On one hand, you've got these powerful open source tools making advanced biomedical data analysis much closer, much more accessible to potentially everyone.
But on the other hand, there's that stark reminder of just how experimental these tools are
Yeah.
and the critical importance of understanding their limitations, especially when you're dealing with data that relates to human health.
Right. So what did that balance between pushing the boundaries of accessibility and being really cautious about application? What does that tell us about where biomedical technology is right now at the frontier and maybe where it's headed? Something to think about. Okay, let's dig into this source you shared with us. It's about a tool for exploring, well, the human brain.
Right, we're looking at a description, just the description of something called Seizure Zone, interactive 3D brain mapping visualizer.
And our mission for this deep dive is really just to understand, based only on the source material, what this web application actually is.
Yeah, how it's supposed to work, what kinds of insights it might offer you about, brain regions and functions.
So what's the main takeaway? What is it, according to the source?
Well, the source describes it as basically a 3D brain model. It's designed so you can explore different parts and see the functions associated with them.
And the source gives examples, right? To make
Yeah.
it clear.
Uh-huh. It mentions things like linking the frontal lobe to decision-making,
Okay.
or, say, the temporal lobe being involved in memory. It tries to visually connect the physical area with what it, well, does.
Got it. And the model itself, the 3D brain, does the source say what it's based on?
It does. It specifies it uses the Distro Atlas.
Distro Atlas.
Oh, yeah.
Okay.
Which is, a fairly detailed map that researchers use. It includes the major lobes, frontal, parietal, temporal, occipital, All the big ones.
And you mentioned visualization. The source talked about transparent rendering. What's that about?
Yeah, that detail seemed important in the description. It suggests this transparency helps you see through the outer layers.
Oh,
So you
yeah.
can get a sense of the underlying structures, not just the surface.
Oh.
Kind of adds depth to the exploration.
Right, right. So you can see the map, see functions, see through it. What else does the source say you can do?
So building on that, the source talks about a feature for semiology examples.
Semiology, like symptoms.
Kind of, yeah. Clinical signs or symptoms. The idea is you can select an example.
Uh-huh.
And the tool apparently highlights the brain areas associated with that specific sign or symptom. And then it gives you a description down below.
Okay, wait. So it's connecting regions to actual, like, clinical manifestations.
Seems to be the idea, based on the description.
And how are those descriptions made? I think the source mentioned something specific there.
It did, and this is really interesting. The source states very clearly that these semiology descriptions are generated using GPT-4o.
The AI model.
Exactly. But here's the kicker, the source text itself. Right after saying the AI generates accurate descriptions, it puts, in parentheses,
It puts question marks in the description next to the word accurate. Seriously.
straight from the source material we have. It then continues, formally user-friendly descriptions. So that little errata about accuracy is, well, notable.
That's pretty upfront. Okay, so given that, what's the overall point of this tool? According to the source, what's its goal?
The source is quite explicit. It's primarily for educational and informational use, not clinical.
Right.
The focus is on interactive learning, and it specifically mentions raising awareness, particularly about epilepsy.
So it's educational, uses AI with a caveat about accuracy. How does this fit into the bigger picture? Any warnings or limitations mentioned?
Oh, absolutely. And the source really emphasizes this. It says seizure zone is not a substitute for professional medical advice.
Okay, that seems crucial.
Definitely. It states you shouldn't use it for diagnosis or treatment decisions.
Yeah.
Don't make healthcare choices based on this tool.
Always consult a professional.
Always.
Yeah.
The source makes that very, very clear.
Okay. So let's wrap this up. Based purely on this source description, what is seizure zone and what does it mean for you, the learner?
The source paints it as an interactive visual way to start learning about the brain's complexities. It uses that 3D Destru Atlas model, links regions to functions, provides those semiology examples with AI-generated text that the source itself flags with a question mark about accuracy.
And the goal is education, awareness, especially around epilepsy.
Right, but always paired with that strong warning. This is not medical advice. It's an educational resource, period.
So it seems like this leaves you with a really important question to think about. When you encounter tools like this that use AI to explain complex things like brain function or medical topics, how does that change how you learn about yourself?
Yeah, and maybe more importantly, how do you figure out when to lean on these cool interactive educational tools versus when you absolutely need to rely on professional human expertise? Where's that line for you?